about it. All right.
One of those pirated movies where the people just like walk by it back and forth on the camera.
Just keep walking by it.
He's like, yeah, the camera's on. I'm trying to watch the movie that's pirated.
Oh my God, Justin, stop it. You're gonna be famous.
I know, right?
Famous.
Oh, I remember this way too big.
Trying to get my face on the screen.
This is my Lamborghini.
Who's that?
And,
Oh, that's me.
you know what I like more about
I know.
I think better Lamborghinis these days. Right here.
Oh, that was probably you. I didn't see.
What is that?
Making
It's
the
this
vlogs.
small stuff on, and it's like, she's
Fire face.
Hey YouTube, this is my first vlog.
So,
That's really cool. Alright. Alright, so guys, let me have your attention now. Alright, this is our last section that we're going to be getting into. We're going to be talking about circles and arcs. So ultimately, I know it's going to sound like a lot more intense, but it's not. So ultimately, if you think about it, we have the perimeter of a circle, which we don't call perimeter, we call it the circumference. And then we also have an area of a circle. Cool. With the perimeter and with, or sorry, better yet, with the,
Oh,
wait, so are you
it's
doing
not
this
good for the video.
because, like, so we can watch it over again?
Gabriella's not here, so I'm sending this to her so she can have the notes.
So you're not putting it on YouTube?
I do put it on YouTube.
Really?
Yes. Alright, so with the circumference of a circle, we can use that to find, like, hey, what if I actually didn't go around my whole circle? What if I only went around a portion of it? Like, here's my circle, I've created a circle on the ground. What if I only went this far? I want to know how far I went. Or what if I'm like, alright, I've created a half circle thing in my house. And I'm like, a thing. My parents had, like, what is it called? Like, we're on the ground. It's like a medallion kind of thing where it's like, no, it's not a thing, but with the tile, when we got new tile in our house, my parents actually cut out and they created a circle which was in the center of our house. And the center was like a mosaic, so it was like a bunch of different pieces creating a circle. Well, what if I didn't want a full circle? What if I only wanted a half a circle? I obviously didn't need to figure out how much material I would need for just a semicircle. And so we can figure out how to find a portion of the circumference and a portion of the area, depending upon how much I truly wanted, or how much I truly have. So in order to do that, we need to use the idea about arcs. Here you guys go, my GOP kids, who towards the end you're just like, I live up on all life. Arcs are like your snow cone. Okay? So we have a major arc. A major arc is, okay, let's actually, I'm going to take that back. We have a minor arc. A minor arc is the length between, in this case, they said AC. It's just a distance from one endpoint to the other. So if I said we had an arc of 30 degrees, you're just like, okay, that's like a portion of my circle, like this portion. Here it is. That's 30 degrees of my circle. Now, a major arc is everything that's left over from what I just told you. So I really hope by now you guys know that a circle adds up to, adds to 360. So therefore, a major arc is what's going to be left over. So if I told you I have a 30-degree arc, my major arc is going to be 360 minus 30. It's what's left over. So my major arc would be 330. So it's just holding the idea that if I give you an arc measurement, to find the rest of the arc, you just subtract from 360. Okay? And it's also allowing you guys to know that an arc, that a circle, has a full arc of 360. Danny, you're not helping your popsicle. You want mango?
Oh, he's like, I got it.
Okay, so naming arcs comes from the angle that is created from the two endpoints on the circle to the center. I am center. Here are my two endpoints on my circle that I can create with my hand. Woo, right? Here's my two endpoints. The arc is the distance from center to your angle. That is your arc measurement. It's kind of like what would be over my head if I had a circle thing right here. Okay, so naming it comes from the angle that is created. So if we have PAQ, so here's my endpoint P, A to Q, the arc that is created ultimately gets rid of center. It gets rid of the angle. So our arc would just be the length from PQ. So PAQ maps to PQ. Because the whole point is that the measure from your angle represents the arc. So therefore, to find the arc, we just take away the angle. We don't need the A. We don't need the triangle. All we need is my snow cone. If I could get rid of my snow cone cup, I would. And all I would worry about is my snow cone. Snow. The next one, the next angle we have is QAR. So Q to A to R. The arc that is created from QAR is arc what?
QR.
QR. Okay, we have RAS. R to A to S. The arc that is created by the angle RAS is what? RS.
So SAP would be SP.
So you're practically just getting rid of A.
You're getting rid of the A. You're getting rid of the angle. Because your angle is created by A,
So it's just the arc.
so it's just the arc. So go ahead. Justin, what did you say? SAP would be what?
SP.
Perfect, just SP.
SAP would be the same thing.
So SP. And then based on Austin's observation, he said just get rid of the A. Bam. So SAQ, the arc would just be SQ. Okay. Just figure out what I'm going to say next. Oh, I figured it out. Okay. So, key concepts, arc measures. The measure of a minor arc is equal to the measure of the corresponding central angle. And I'll show you what I mean back on the example that we labeled the arc measurements about. Or we'll see it here actually, so we'll let it go. The measure of a major arc. So I told you guys this back in the instruction, or back in the definition. What do we know, how can we find a major arc? What did I tell you guys we'd have to do? What would you have to do to find a major arc? I give you a minor arc. A minor arc is equal to its corresponding angle. Perfect. You're going to subtract the major arc, or to find the major arc, subtract the minor arc from 360. So if we had an arc of 60, 360 minus 60, our major arc, our leftover arc would be 300. This is circle. I thought I was funny. 300? All right, the last thing is a semicircle. So the measure of a semicircle. Semi means half. So what's half the measure of a circle?
180.
180. Hear that crack in the back? All right. Can we talk about it? Can I go ahead and we can actually talk about major, minor? Major, minor. Okay. So 17 and 18 show us an example discussing major, minor, whatever. So it says, the measure of arc, we know it's an arc because it has a little rainbow over the name. So it's saying the arc of RT is equal to the measure of the angle RST. So they're saying whatever our angle is, that's a central angle because it hits at center. Last I checked, is S center of a circle. Yes. So whatever the central angle is, your arc measure is. So therefore, RT is equal to what?
RST.
Okay, yes, those are equal. What is their measure now? 50 degrees. Your angle's 50, and it says whatever your angle is, your arc is. So that means that my arc, RT, is also 50. They're identical. Now to find my major arc, the leftover stuff,
You subtract it from 360.
we subtract from 360. So it says to find the arc TQR, it is equal to 360 minus my RT, my measure of my arc RT. We said that the measure of arc RT was 50. So we're going to subtract 350 from 360.
310.
So 360 minus 50 is 310 degrees. Alright, a cool concept that we know about arc addition. Super cool because it's going to help you in all life things. Says the measure of an arc formed by two adjacent arcs is the sum of the measure of two arcs. So it's saying to find my total arc of A, B, C. That is the same if I just add the length of AB. So here's the length of AB. And if I also added the length of BC. So I can either add them up together, just say, okay, that's 30, that's 40, that's 70 total. Or you can just say, hey, oh, I know 3 plus 4 is 7, add a 0, it'd be 7. They're just saying as long as your arcs are next to each other, you can add them together. Super cool? I don't know. However you want to look at it. It's just saying that as long as your arcs are right next to each other, you can add them together. So me and Jade are arcs, we can be added together. So using the circle at the right, we are going to use the idea, they gave us an example. If AB is equal to 40 and BC is equal to 100, what would be the length of the arc ABC? Add it together. The length of AB plus the length of BC can obviously tell us ABC. So 40 plus 100 is equal to 240.
140.
Oh. Okay. I was like, whoa, hold on there. Hold your gotchis. I have no idea what that means. My mom used to tell me that all the time. Gotchis? And she always used to do it when she had to slam on the brakes. She would hold me back like a seatbelt. She's like, hold your gotchis. What does that mean? I don't know. No.
Ask her.
I think I have, and she's like, I don't know, it's just a saying. I don't know what saying where she's from, but whatever. It says, if AB is X and the measure of BC is Y, then the length of ABC, just add them together. X plus Y. Can we simplify X plus Y? No, so therefore, the length of ABC would just be X plus Y. Super cool. If you need to get a haircut, I can easily cut those for you.
No, I'm
Oh, Cassidy and Danny. Are you sure you deserve to go, Danny?
Yeah. Okay. Can I get a forecast of you?
Alright, let me erase this real quick so I know. Alright. Alright, Alright, so finding the measure of an arc. Just talking about that a central angle is the same degree as its arc measure, so we can easily find arc measures or angle measures. So it says a measure of PCR. So PCR. What is the length, or what is the measure of that angle, PCR?
77.
77. So therefore, the arc that was created by that angle, what do we know about a central angle and its arc? They're the same. So therefore, the arc of PR has to be equal to 77. So whatever your angle is, your arc is. They are identical. They are congruent. They are the same. They are equal. They are equivalent. Now, what if we have the measure of QSR? I totally wrote that backwards, but we're going with it. So if we have the measure of QCS, talking about that angle, we want to know what its angle degree is. Why do you know it's 28, Austin?
It says right there.
No, that's talking about the arc. It's saying that the arc QS is 28.
Because it connects with the center of the circle, so it's the same thing.
Perfect. Because our arc is created by the angle QCS, our arc and our angles are the same. So since QS was 28, our angle QCS is the same. Great. Just more getting you guys in the good flow. Well, let's get down to our circle. Okay, the circumference of a circle. We have two formulas for the circumference of a circle. It depends upon what you got. So C stands for circumference. We can either do it one of two ways. One way is saying that you have your diameter. Your diameter is the full length from center. So it goes from one end of the circle through center to the other end. It looks like a Pokemon ball. If we have our diameter, we can find our circumference by pi d. And you will begin to notice today, anytime we are finding the circumference, the arc length, the area, or the sector area, we keep everything in terms of pi. So we actually do not multiply it out. We just leave it as pi. So you multiply all your real numbers, and then you just leave pi. Right. You just kind of tack it at the end. Right. So that's one way that we can find it. Or the other way is if we are just given a radius. So a radius is just from center to one side of the circle. And our formula would look like this. 2 pi r. So the reason why we have two formulas is because if you are given the diameter, you could just plug that straight in, pi d. Or if you were given the radius, technically it takes 2 radii to make a full diameter. So that's why we multiply our radius by 2. So if you're smart and just say, hey, I'm going to double my radius and then plug it into this original equation, knock yourself out. But the formula 2 pi r takes care of that doubling your radius for you. Okay, so this is a very complex problem. I want you guys to bear with me. Go ahead, Dave. So we are going to be finding the circumference, but we're going to be finding the circumference in a different way. So let me read the question and I'll kind of demonstrate how you guys think about it. So it says, a car has a circular turning radius of 16.1 feet. So that's saying if I'm a car, I can turn in a complete circle going a distance from wherever center would be 16.1 feet. The distance between the two front tires is 4.7. So here I am a car, here's my right tire, here's my left tire. The distance between the tires is 4.7 feet. We're going to take that into accountability in a second. So technically if I'm driving, I mean, can you guys agree with that? Your tires never touch no matter what you do. They're always the same distance apart. Although it looks like I'm walking with a stick up my butt. But no matter what, they're always the same distance apart. It says how much further does the tire on the outside, here's my outside tire, it's always on the outside, here you go outside. How much does the tire go, or how much further does the tire on the outside turn than the tire on the inside? Think about it. If you were driving constantly in a circle, say you drove your car in a circle for 20,000, or let's do 10,000, because that's typically when you need to get your tires rotated. No, I lied, that's 5, isn't it? Every 5,000. So you drove in a circle for 5,000 miles, straight. You didn't do anything. I'm pretty positive you would probably need new tires, one. The reason why you get your tires rotated is because when you drive, you do favor a side of your car. You are going to see, if we find the circumference, we're going to see that one car's tire is going to go further than the other. Think about it. When I'm walking right here, when I'm same distance, can you see how many steps? I need to do a random step on my right foot more than my left foot. That's why I'm walking like a freaking idiot. So my distance on my outside leg is far more many steps than my inside leg. It's like 1 to 2, 1, 2, 1, 2. So, huh? Correct. So your outside tire is going to travel further. So when we do this, we're trying to figure out how much further does it travel. Okay? So we have the two circles have the same center. Here's your center. We want to find the radius of the inner circle, and I'm going to ask you, are we going to add to find that? Are we going to find, we know that the distance of our full circle is 16.1, and we know that the distance between the tires is 4.7. So to find this inner circle, are we going to add 16.1 and 4.7 together? What?
There you go.
Yes. Or are we going to subtract?
Really?
No, I saw you.
This.
Yes.
There you go.
That's what you get.
I kind of heard it on my knees.
Yes, Martine, go ahead. Okay. I know that you're next, Shelby.
Good.
Okay. So we know that our outside circle, here's my outside circle. I didn't see it. Is it in your bag?
What?
Her phone?
What do we call it?
You can leave it in the bathroom.
I don't even think I took it.
What's the number?
Really gonna vibrate?
Or go off. I don't know what it's on.
Where it up?
532.
5, 3, 2.
Can I go to the bathroom?
I have two people out when they get back to me.
42. Why is it not going?
She found it. It's in her boobs.
I've been doing that too. I forgot. I do that whenever I go to the bathroom because I don't want it to fall in the toilet, so I go with that.
Okay, she found it. Alright, so we want to find, we're ultimately going to be finding two different circles. We have our outer circle, which we should already see from center to a end. We have a radius of 16.1. Now we want to look at our inner circle. That's going from center to this first circle. So my question to you, we don't have that radius. We need to find it. So are we going to add 16.1 and 4.7 together, or are we going to subtract 16.1 and 4.7?
So what
Why are we going to subtract?
Because if you were to add 4.7 to 16.1, it would just extend the circle.
Correct.
You're not trying to extend.
We don't want to extend our radius. We want to take care of the radius we already have. So we're going to subtract. So that what is the radius for the outer circle? Our outer circle we already have, 16.1 feet. Now, the radius of the inner circle, we're going to subtract 16.1 minus 4.7. Do you guys agree that we need to subtract? If we added 4.7 to 16.1, it would just make that radius longer. We're not asking for a bigger radius. We're wanting to cut that radius to figure out what we have in our inner circle. So 16.1 minus 4.7, we end up getting 11.4. So our inner circle has a radius of 11.4 and our outer circle has a distance of 16.1. Honestly, I want to make sure, do you guys see why we would subtract? I will try to demonstrate it as best as possible, but I need to make sure that you guys get it. All right, now we're trying to find the distance it traveled. Who traveled further? Well, distance around, if I was talking about a square, and I told you I went on a square, I went on a walk around a square, and each side was 4 feet. How would you figure out how far I went if I traveled the square once? How would you figure it out? How far did I go if one of my sides of the square is 4 and I traveled around a square once? What did I do? If I walked around a square one full time, and the square, one of the side lengths is 4 feet, how far did I travel?
If you walked around the whole square?
If I walked around the whole square.
16.
16, what did you do?
Multiplied by the 4 sides and times you know what I'm talking about.
Correct. What distance is that? Is that the area of the square?
That's the perimeter.
It's the perimeter. So if I want to find the total length they went around a circle, I'm not going to be finding the area. I'm going to be finding the circumference. So we have to find the circumference of the outer circle. So I'm going to erase this. I'm going to scroll it up. We're going to find the circumference of the outer circle. What formula are we going to use? I gave you 2 different formulas depending upon what you have, whether you have the diameter or whether you have the radius. So what in our problems, in our circles, we have a circle with a radius of 11.4, and then we have a bigger circle with a radius of 16.1. So what formula are we going to be using? Circumference equals pi d or circumference equals 2 pi r? 2 pi r, because we have a radius. So let's plug shit in. It says keep in terms of pi and find a decimal. When we plug in for pi, I do not want you to be using the pi button on the calculator. I want you to plug in our ratio. Our ratio that we have is 3.14. So it wants us to find the circumference of the outer circle. Outer circle, big guy. Here's the one we're going to be using. So circumference is equal to 2 pi r. My radius is 16.1. The first thing that we want to do is we want to make sure we keep that in terms of pi. So when we keep it in terms of pi, that means we multiply our whole numbers together and just leave pi on the end. So we're going to multiply 2 times 16.1. 2 times 16 is 32. And 0.1 times 2 is 0.2. So we get 32.2 pi. That's your first answer. Leaving in terms of pi means you multiply your whole numbers together and you tack on pi at the end. So 32.2. Now, I want you to go ahead and give me that answer rounded using pi as 3.14. So you're going to plug into your calculator, you're going to multiply 32.2. So did I get the right answer there? I just when I divided it, it was just weird. Oh, I probably just did it for mine. Okay, can you go back and fix the 2 that got that? Okay. All right, when you multiply that, so 32.2 times 3.14. 101. Okay, I was going to say there's no way it got smaller. Okay. 101. 0.11. Okay, so my outer circle. Here's my outer tire, my right foot. It went 101.11 feet total. Now we're going to find and solve for the circle of the the circumference of the inner circle. So now we're no longer going to be using our radius of 16.1. We're going to use our radius of 11.4. Again, we're talking about radius, so the formula that we're going to choose is 2 pi r. I don't want to use pi d because I don't have the diameter. 2 pi r. I'm going to plug shit in. 2
Wait, how did you know that it was 11?
because we subtracted.
You can explain it to me.
Okay.
Okay, I got those issues. Yeah.
We wanted to take away the 4.7.
Okay.
We didn't want that length. So the total length is 16.1. We want to take away the extra length, so we would subtract. If we added, it would have made it longer.
Okay.
Okay? All right, sorry, we're good. All right, so now we're going to plug in our radius. We have 2 pi, our radius of 11.4. Let's multiply that. 2 times 11.4. Keep in terms of pi first. So 2 times 11.4, 22.8 pi. Then we can go ahead and we can simplify and plug in when pi is 3.14. Perfect. So my outside tire traveled 101.11 feet,
So how
and
did
my
you get 71.59? What did you
because we multiplied 22.8 times our ratio of pi. Pi we can plug in as 3.14. So we plug that in. So typically I'll have you keep it in terms of pi unless I ask for a decimal. But usually we're going to keep it in terms of pi, so 22.8. So my outside tire traveled 101.11 feet and my inside tire traveled 71.59. Let's figure out how much further my outer tire traveled than my inner tire. So it says find the difference between the two distances traveled, outside tire versus inside tire. So my outside tire was 101.11 minus the distance of my inside tire, 79.59. Subtract that. 101.11 minus 79.59. How much further? Say it again.
71.59.
No way it would have been 71.
21.
21?
No, the number.
Oh, what is it?
71.
Oh, 71. Thank you. 71.59. That makes better sense. And then what was the difference, Sadie?
Oh, I put 79.
Okay, go ahead and fix that.
29.
29. Yes, Gabe. Oh, were you going to answer it? Sorry, Gabe. 29.61. So 29.61 feet. Do you see why we have to get our tires rotated? Because no matter where you're driving, you do favor one side or the other depending upon where you're driving. Most likely I'm gonna be favoring my right side if I'm going up to Flagstaff, and then I'm gonna favor my left side coming down from Flagstaff. Kind of just depends upon where you are going, and that's why every 5 miles they have you switch, so then that way you can balance your favorism.
Every 5 miles they have you switch what?
Tires. They have your tires rotated.
That don't make sense.
What do you mean? Every 5 miles, or every 5,000 miles, you're supposed to go into your dealership
I'm like, what?
and get your tires rotated.
Yeah, I'm like every 5 miles I'm seeing it.
Oh, sorry, 5,000. All right. Maybe I should just get my calculator back. You guys are just killing me, small. All right, sorry, it's 29.52. All right. Now we can use circumference to find arc length. Arc length is saying if I didn't travel a full circle, say if I wanted to just travel till here, I can figure out the distance I traveled from here to here. by using the arc length. It uses circumference, shut up. It uses circumference, however, it's talking about a portion, and this is where we're going to have to know our arc degree. So how much do we go on an arc? So the length of an arc, to figure this out, we need to know the length of the arc. So we can find the measure of the arc. Either it will be given to you or it will give you the measure outside of it. So if it gives you a circle, it says this length is 60 degrees, you have to find the rest. It all depends. It'll say by the darker shaded line. It's the measure of the arc over 360. Times, this will tell you our distance, like how far did I go around my circle. Because if I went a full circle, that would be 360 divided by 360. That would be equal to 1, which would be your circumference. So this would tell you how far you did go. To figure out the rest, you have to multiply this ratio, by our circumference. Either 2 pi r, if you're given the radius, or you will have to take your measure of the arc over 360 and multiply it by pi d. So it depends upon what you have. If you have your radius, you're going to plug into 2 pi r. If you have the diameter, you're going to plug into pi d. The measure of the arc over 360 is going to be able to give you a decimal, which helps you relate how much you actually truly went, how much rotation of the circle you did go. That's fine. I'm still good. All right. So let's try it. Let's work this out. So find the length of the arc AB. So it's telling me that we're wanting to use this right here. The length of AB. Are we given that degree? Are we given the arc length of AB? No. So we have to find it. And the pieces of information that we do know is we know that a full circle is what? 360. A semicircle is 180. And to figure out what we're missing, we can either subtract from either of those, depending upon what we're looking at. So to find the length of AB, we are given, I'm going to tell you what I saw, and then you guys can decide whether or not you want to do a full thing. I see that the length of AB is part of a semicircle. So all I need to focus on is knowing that a semicircle is what?
180.
180. So I know that my AB is part of a semicircle. Now to figure out what the length of AB is, they gave you the angle that offsets AB. What is the angle that offsets AB? 70. So we can take into account that we already have 70 degrees. We already have him. So we want to get rid of him. So I'm going to subtract 70 from my 180 to figure out what's left over then. We are left with a degree of 110. So the length of AB is 110 degrees. If you wanted to sit there and add it and take care of 360, that's fine. But you would have taken 180 away from 360 to get 180, and then you would have taken 70 away from 180 to get 110. So you're just adding an extra step. I really hope by now that you figure that if you have a diameter, you are talking about a semicircle, because a diameter creates the semicircle. So we are talking about an arc length that is 110 degrees. Now, I'm going to rewrite the formula, but I want to know what form of circumference we're going to be talking about. Are we going to be talking about 2 pi r? Are we given the radius? Or are we going to be talking about pi d, because we were given the diameter? Pi d, because we have the diameter. We have the full length of the damn circle. We have 4. So now we're going to use arc. Our formula is arc measure over 360 degrees times Cassidy said we're going to be using pi d because we have diameter. So now we can plug it in. Our arc measure, what did we find it to be?
110.
110. So 110 degrees over 360, because that's my formula, times my big multiplication dot, pi d. We can replace d though. We have the diameter. What is the diameter of our circle? 4. So the first thing I would do is figure out the decimal. If this is more than 2 decimal places, round it to 2. So I'm going to put in my calculator. I said I was going to get it because you guys are making me 0.3. Let me verify that. Perfect. It is greater than 2 decimal places, so we're going to round it. It's 0.305. And Cassie's 100% correct. That is going to be rounded to 0.31.
So we divide 110 by 360.
Yep, 110 divided by 360 gives you 0.305555555555. Okay. So we were able to round that 555 to 3.31. Then we can go ahead and multiply that by pi times 4. Leave it in terms of pi. I didn't ask for a decimal. So now the next thing that we can do is multiply our whole numbers together. We can take 0.31 and multiply it by my 4. 0.31 times 4.
How's your 0.31?
110 divided by 360. 110 divided by 360. What do I get?
Oh, so you have to round.
Yep, we have to round it, 0.31. So 0.31 times 4. So 0.31 times 4. We end up getting 1.24 pi. Our units is in meters. I leave it in meters because remember, circumference, perimeter, we don't square that. It's not talking about the 2 lengths to fill up a circle. It's talking about the 2 lengths that create the circle.
Why'd you leave it like that? Why didn't you include pi?
I did, it's right there.
I mean,
Or why didn't we multiply it by 3.14? Because the higher you go in mathematics, the more we like to leave it as clean as possible. So we like leaving it in terms of pi because then it leaves out the irrationalist. Because if we really, that's more precise, 1.24 pi, than multiplying it by 3.1415926535897. We want to get as precise as possible. In a lot of systems, if this was a real life situation we're asking, a system will put that into consideration. It knows what pi is and can give it a better estimation than we can. Okay? All right. Now, just like we can find a portion of the circumference, we can also find a portion of the area. That is called sector area. So sector area is the inside stuff between your central angle and your arc. So a sector would be the inside that I just colored RST. A sector is just a region bounded. It's a portion of the area. So like I said, if we made a medallion or whatever it's called in the middle of my floor at my parents' house, then we can obviously see, like, what if my parents didn't want a full circle? They just wanted like random parts of circles scattered around the house. We needed to obviously figure out how much cement we needed to fill that area. So that's when we would take into account a sector area. Okay. Area of a circle. The area of a circle is, does anyone know what the area of a circle is? We really don't know what the area of a circle is.
Pi times.
Pi times your radius squared. And remember, if I'm asking you for area and for whatever reason you were given the diameter, you gotta find the radius. So your radius is your diameter cut in half. So if your diameter is 10, your radius is 5. If your diameter is 20, your radius is 10. If your diameter is 30, your radius is 15. So you need to remember that your radius to find it, you just cut your diameter in half. Okay, because there's only one formula for area. We don't have diameter involved at all. And what it would look like is your center to a endpoint is your radius. And it's talking about, if I could lightly draw this, it's talking about all this inside portion of my circle. So it's more like a lightly drawn, you could lightly shade. That's what the area is, it's the inside. If I had to fill up a circle, you need to cut those, Danny. I swear I'm going to come to your house and cut your brains for you.
You can't see your eyes.
Okay. Let's, what? Diameter divided by 2. I would write diameter just in case you don't know that D is diameter. Okay. Just drawing that the area is the inside portion of the circle, not the outside region. So finding the area of a circle. Here's a wrestling mat. This is grosser than anything else. It says, what is the area of a circular wrestling region? Hey, Justin, Danny.
What's so wrong with their clothes?
Huh?
What's so wrong with wrestling? I can
You can get nasty things. Okay. So what is the area of a circular wrestling region with a 42-foot diameter? So we need to find the radius because our formula for area is pi r squared. So to find the radius, Justin,
What? Oh, sorry.
to find the radius, it is equal to your diameter cut in half. So your diameter divided by 2, we can plug that in. Our diameter is 42 divided by 2. What is 42 divided by 2? 21. So we're going to be using the radius of 21. Solve for the area of the circle. Area of circle. And it says keep in terms of pi and decimal. So we're going to take it a step further now. So area is equal to pi r squared. We're going to plug it in. Pi times our radius. We found our radius to be 21. We're going to square that. First, we're going to keep it in terms of pi.
Stop.
So 21 squared, 441. And we're keeping in terms of pi, so it's going to be 441 pi. And our units were feet squared. Now, I also asked not only to keep it in terms of pi, but then go ahead and create it in a decimal. So take 441, multiply pi, we used 3.14, and Gabe, you look so eager to tell me, what did you get for 441 times 3.14?
1384.74.
Feet squared. So that's how much foam mat I would have to use to create a wrestling mat.
Oh.
Like, it's not a lot. It's gross.
It's only girls from that
I know, but you can never trust them either, though. Like, no matter, like, I'd be scrubbing that with, like, bleach every night, and it probably could still be dirty. I know, but it could still, you know, it's still not good enough.
What is?
Wrestling mats.
Oh. I'm not reading one house.
Have you? But see, that's what I'm saying. You say that they do clean it, but then you can still end up with it, right?
That's because, no.
Oh.
The guy that I was wrestling, he had it on him and he rubbed it on my cut that I had on my arm.
Oh.
Wait, what?
So I didn't think, why could they wrestle then? Like, I would think that they would.
Tape it.
Oh, that's enough?
Put
Obviously.
a Band-Aid over it and like, it still gets through, I don't know.
Oh my gosh. What do you do with ringworm? I'm not asking you, but you asked, you called my name. Yes.
I was wondering which one.
Oh, ringworm. In wrestling, because that's what you get from wrestling. And, what is it, cauliflower ear?
I got that too. They had to bring my ear out.
How do you get a cauliflower ear?
You basically break the cartilage inside your ear. And
But how? Like how?
Wrestling.
Wrestling.
Somebody gonna pull your ear? I'm like, get
No, they
the
have the earmuffs and they have the earmuff spray where like they come apart. They tend to go down or.
I mean, think about it. You're not sitting there like, oh, you touched my ear, I'm going to get you. You're trying to get them like a lock or some sort. My husband was in he did MMA, and then his buddy was a wrestler at high school, so it was always really funny to watch because it's two totally different forms. And my husband used to get his butt beat every time his friend would do wrestling because he's like, I don't know how to break that out, but if he was going to sit here and do MMA, I'd get him an armbar like in a second. And I'm like, whatever, I just stopped listening. I should be careful because it's on YouTube and he can go watch me. Love you. Okay. So just like how we can find a portion of the circumference, we can also find the portion of the area. Danny, this is like the 95th time that I asked you to move your head up. So you can either choose to pay attention or not. Or not. Okay. So, like I said, we can find a portion of the perimeter, but we can also find the portion of the area. The formula is very similar to the arc length. So we have to, the first thing is we have to take the measure of the arc, in which the sector, the measure, the area that we care about. So the measure of the arc. Okay, hold on. I'm writing this like very measure of arc. We're going to take the measure of the arc and divide it by 360 because again that's a full arc. Then just like what we did with the arc length, to find the sector we're going to multiply it by the area. We're going to multiply it by pi r squared. And what this looks like is if I gave you A, here's center, here's B. If I give you the radius, if I wanted to find the area of just this portion, we would need to know the radius, plus we would need to know the arc in which I truly did cover, and we can then find the area of that portion specifically. And yes, just like with arc length, I can give you this arc, I can give you everything else. You have to know that you're either going to subtract it from a full circle, which is 360, or you could also take into account that you could be taking it from a semicircle, which is 1/8. Okay. Cassie, are you? Okay. So, here's just giving an example. If I give you the measure of the arc, we're just talking about our beginning portion, the measure of arc over 360. So the measure of the arc is 60, so we're going to put 60 over 360. And what they did is they were able to simplify both of those by 60, because 60 goes in the top and 60 goes in the bottom. 60 divided by 60 is 1. And 360 divided by 60 is? Yes, sorry. So we get 1/6. However, when I'm asking for it, I want you to actually simplify that out. So what I actually would want is 1 divided by 6. So we're going to take that a step further, 1.6 or 1 divided by 6.
0.17.
And that is rounded. So then we would go ahead and we could take, I just write really huge. So now we're going to take in the measure of our arc and we're going to use it to find the sector area. So that means that we are going to take our ratio, our 1/6, and we're going to multiply that by pi r squared. So we can figure out the portion I have. I am talking about 1/6 of the circle, and then I would multiply that by the area. But like I said, I like putting in forms of a decimal, then multiplying. You will see. Another example we have is we have 120 is the measure of the arc. So our formula to figure out the portion of the circle we're talking about is measure of arc over 360. So that would be 120 over 360. I'll cancel out my zeros to make it nice and easy to simplify. 12 divided by 36. How can I simplify 12 over 36?
6.
I can do more than 6. 12. You could totally, Joel, was that you?
Yeah.
You could totally do 6, but then it could be simplified again because it would be 6 over 36. And then you would just have to see that 6 can also go into 36 as well. Okay? So you can divide by 12. 12 divided by 12 is 1. And 36 divided by 12 is 3. And if this was an actual problem, I'd want a decimal.
0.33.
So it would round to 0.33. Now plugging that into the formula, our formula says it's our measure of the arc over 360, so we got that ratio to be 1/3, times pi r squared. So finding the area of a sector. It says a circle has a radius of 4 inches. Here's my circle, here's my radius of 4 inches. What is the area of a sector bounded by a 45-degree minor arc? So I'm going to draw this out. This looks nothing like 45, but no one said I'm perfect, so I'm not. So here's a 45-degree minor arc. Leave your answer in terms of pi. So we're going to leave it as pi. What is the formula of the area of a sector? So how do we find it? All right, Gabe, go ahead. I heard you say it as I was coloring.
Measure over the 360.
Measure of arc over 360, then what?
Then times pi r squared.
Did you say pi?
Yeah.
Okay. It sounded like you said times by r squared, so I just wanted to clarify that. So yes, you're going to take the measure of your arc divided by 360, then multiply by the area formula, pi r squared. So plugging this in, we get the measure of our arc. What is the measure of our arc?
45.
45. So we're going to get 45 over 360 times
Pi 4 squared.
pi. Instead of r squared, we can say 4 squared.
1125.
So that'd be 16.
So, perfect. 4 squared would be 16. Let's simplify this fraction right here. What is 45 divided by 360? 45 divided by 360. Say it again. 0.13 times. Jessica, you already told me that 4 squared was,
16.
so we would get 16 pi. Now, we can multiply 0.13 times 16. 0.13 times 16 to 0.08 pi. What are our units? Inches squared. It's called sector area. Your area better have units squared. Your circumference, your arc length is just units.
Even all the other problems, they were just like,
Not your circumference. This one was inches squared.
No.
This one was feet squared. But then your circumference is just
Yes.
units. So it's just meters or just this or okay. You're ridiculous.